We do, and you can use the system to tell, like for example, you made a car, you can even test it by using the model to hit the pillars, hit the big stones, and see whether the car will compress or the cars will stand the test of hard this. So all these things are done before Toyota, before Mercedes, before all these big car, Lexus, all these big car companies. Before they make car, they do the modeling, they do the simulation modeling first, and they test it, and they can predict about the future. Then another advantage, the third advantage, is to train people who use the system without putting them at risk. It's just like flight, for example, airplane. You don't train the pilot with real airplane, with real people. You don't train the pilot with real airplane, with real people on board to test or to train them. We use what we call the simulation modeling. Okay, they use the simulation modeling of the real airplane, So they fly the simulation, the simulated airplane. That's what they sit and they fly it. And to them, when they sit in the model, the program room, the control room, it will be as if they are inside the plane and they are flying the plane. So that's how they train. The landing, the takeoff, and how you put this autopilot in the air to fly. All this you learn with the model. So model helps to train people how to use the system effectively and efficiently to avoid the risk of real life problems like crashing and so on and so forth. So this is one big advantage we can get from this. And then the fourth big advantage from why we do computer modeling is the fact that it helps us to investigate a system in great deal. Okay, a model of system can be zoomed in and out or rotated to see the possibility and the flexibility and the virtuality of that system. Okay, so in modeling you can stop time. In real life you cannot stop time. You can stop time, you can rewind, you can go forward back and correct whatever problem in the design so that we can get more and more accurate system. That's why today we're getting more and more automated, more and more accurate system. Why? Because before those systems were made, they've been modeled before, they'll be simulated, they'll be test run, they'll be investigated, they'll be able to predict the future outcome, and they've tested them. So all of these have been put into advantage. So as a result of that, the product, the real life product that comes, like the car that comes out, becomes a better version of what we had before. So now let's take a look at example of computer modeling. A good example of computer modeling. Now, designing safer cars. Now today we can design safer cars, or like in those days. Because in those days we just build a car. We want to build a car, we build a car. Whether it's safe or not, we don't know. Okay? We just trust that the material we use are good enough, and there is no proper testing of collision and so on and so forth. But today we can design safer cars. A computer model of a car can be used to test how safe the design of the car is in a crash. How safe. So when we do the modeling, we will crash them with other cars in a model, only in a model, not in real life. And there will be, when you watch movies, when you see that they are crashing cars, bombing houses, they are actually they are not bombing the real houses. And they are not crashing the real cars. Only in few cases, they crash the outdated cars. When you see the bomb car, it's actually a model. They cut the modeling part and add to the real movie. So most times, they use the modeling of crash, of accident, and then they put in the real movie. Because sometimes some models are so like the real one, okay? Okay, so we say a computer model of a car can be used to test how safe the design of the car is in a crash, right? Now the virtual car can be crashed over and over again to see how safe it is and how effective the design is. The effect investigated and the design easily changed if it's not good enough or it is as safe as possible. So when you design and you see you crash the car compressed so much, then you have to change the design with the materials and probably reinforce the materials that you're using until you get something that when you crash, it's a little or nothing will be seen from the damage. So till then we will continue to improve the model before we build the real one. This is much quicker and cheaper than building a car and then crashing the real cars. Like after you build the car and crash the real cars, you lost millions of dollars, or you lost thousands of dollars. So you can see that crashing already existing car that you built is way more expensive for you. It's costlier than a company that do the simulated one and crash the simulated one and before they build the real car after they've got the desired output. Now let's go to weather forecasting. Okay, let's go to weather forecasting. Computer model of a weather system can be used to predict the storms. They use the computer model to predict the storm that is to come. And the wind pattern, the temperature, and a whole lot of humidity, all of these environmental characterizations will be put into cognizance for the whole planet, and then they need to be simulated using very powerful computers. So we can put the wind, depending on the wind in a particular place, depending on the temperature in a place, the humidity, okay, the rainfall, all the parameters that determines the weather of a place will be put into the simulation. So in the simulation algorithm or the simulation program, you're going to put all the parameters, humidity, temperature, rainfall, sunshine, all of this will be put into the program, and then it will be simulated. So it's very difficult to make an accurate model since our planet is rather big. Because in the case of planet, the planet is big. If you're simulating the whole planet, so your model will be near to what is this, but may quite be different from the actual result that we will go to see in the future. The weather forecasters can use it to fast forward into the future to see the predictions of what the weather will be tomorrow, next week, next month, and so on and so forth. So they just put all these parameters of temperature, wind, windfall, wind direction, wind vane, and all of these things, pressure, atmospheric pressure, humidity, all these parameters we put in the computer, we simulate for the planet, and we can predict what is to come. The weather condition of next week, next day, next week, next month, and so on and so forth. Now, since weather is so complex and the models are not yet accurate enough, often the weather forecast is wrong. So sometimes you see that we predict that it will rain in Kuala Lumpur today, might not rain. But most of the time it will rain. But sometimes you see that the forecast do not come according to, because it was a simulated model that they use in forecasting. Another place where we use model, okay, we've talked about weather, we talked about designing cars, practical application. We talked about how it's being used in weather condition. Now building better bridges. Before we build bridges, we have to do the simulated model. Okay, if not, our bridges will collapse. Cars driving on the bridge will fall into the river or the sea, and then we will have problem, or the ocean, we will have problem. So we have to do a simulated design and test the design to see whether the bridge can stand the test of time. So if the bridges can stand the test of time, then we are good to go. So bridges have to be able to survive extreme weather conditions. So when we design this, we will put very harsh condition in the simulation program. Very harsh condition. Extreme winter, like beyond freezing point, okay? Extreme winter, like really -30, -40. We can use it for the simulation of the bridge and see whether winter condition, very low temperature can contract or expand or destroy our bridges. We put also very high temperature, like 40, 50 degrees Celsius, to see how the bridge can stand these extreme weather conditions. So if it's not good enough, we improve the parameter of the design. So in order to achieve a more desirable outcome before building the bridge, because we cannot build a bridge and before we test, we have to do a model and test the survival of the bridge before we build the bridge if it can withstand the extreme weather condition. It is obvious not practical to build a real bridge first and then wait for it to go down with storm before you know what to do. Okay, we should be proactive. We should not be reactionary. So as engineers, as scientists, we should be proactive. We should predict what is to come. So we should do the simulation modeling. This is how we get things in a better perspective. So instead, a computer model of a bridge is created and tested for virtual storms. So instead of building the real life first and then you wait for it to collapse with the storm, you do the simulation modeling and you put very harsh storm, you put tornado, storm, harsh one, bushfire, everything. You simulate with the bridge and see if the bridge can withstand this design. So if the model breaks, then it's quickly and cheaply we redesign and retest whatever we have done. So that is that. Then also, bridges can also be tested to see if they can cope with heavy traffic. Because there are sometimes where you have heavy traffic on the bridge, especially if you have an island in your country, from the mainland to the island, sometimes the bridge will be jam-packed with traffic. So when you design a bridge, you have to test it with heavy traffic. When there are so many cars, thousands of cars on a long bridge, what will happen to the bridge? You have to do the simulation testing to see if the bridge can withstand heavy traffic. If yes, then it's good to go. If no, we have to redesign and reinforce the parameters that we're going to use for this. You have to even test with heavy truck. Okay, you assume heavy truck on the bridge in a traffic. Assume a traffic of only trucks, heavy trucks, carry tons and tons of cement, tons and tons of heavy metals, and will the bridge be able to stand, or will the bridge just collapse? So all of these have to be tested before we build the actual bridge. So as engineer, we should know how to do computer model, do simulation of the real life situation, and see and test it with very harsh conditions, available parameters and conditions, to see whether it can stand the test of time. Now we go to running a business. A computer model of a business can also help to predict the future profits. Okay, now we can do the break-even point, the spreadsheet, to see your sales outcome, your revenue, and all of these things, and to see whether you're going to make profit in the future. So even before you start business, we can now do a computer model to see how this finds its way and help your business to survive. If the working of the business can be modeled accurately in particular the financial system. Because when you're doing business, you look at the financial system first. So we do the financial modeling to see whether the business will survive. And then these models can be used to make prediction whether the business will survive or not. The models are used to help to answer questions like what if, all this type of what if this happens, what will we do? So what if we decrease the workforce by 50%, will the profit increase or decrease? All these what if parameters you key in the spreadsheet and do a model, a simulated model of it, and see whether you're going to do well. Based on the answers the model gives, then the managers of the business will be able to make an informed decision. Now another application of model is training pilots to fly an aeroplane, which I've highlighted in the earlier discussion. Here, trainee pilots have many hours of lessons in flight simulators. We call it flight simulators, before being allowed to fly the real airplane. So you see, it will be as if you are in it and you'll be trained how to fly. You go to learn with many hours till you master how to fly the plane. Before they will give you an expert to fly with. Expert will sit with you and will fly with you. And when you begin to be very good, then you can start flying with a team, okay, as a professional. But you learn with simulator. It's called the flight simulators. This is, if you go to pilot school, this is what you learn. This is what you learn with simulators to fly in the airplane. Flight simulators have almost exactly real life airplanes. Okay, they have almost exactly real life airplanes since they are controlled by a computer and with a very accurate and realistic model of the airplane. The main difference is that the simulator can actually crash. The simulator cannot actually crash. That's the difference. But the real life can crash. So pilots can make mistakes without putting anyone's life at risk. So when you learn with simulator, even if you make mistakes, you're not putting anybody's life at risk. Or like you're learning with the real life. Like in the case of car now, we learn how to drive car using the real car. Okay, because it's not so risky. You can only crash a little bit if you're learning. It's not like big accident, you're not on the highway. You don't learn car on the highway. You just learn in a field or in a place. You get lost, you don't know what to do, you match the brake and stop the car. So we learn with the real car, but airplane, you know, is going to fly off the ground. So you cannot learn with the real airplane. So in order to save your life and save the life of those on board with you. Okay, so that's that for that. And flight simulators can provide a pilot with a number of highly realistic flying situations like the storm. So the simulators has things like very heavy storm, engine failure, low cloud, hiding the runway. You can see the runway properly. So all these challenges will be put before you during the simulation stage, and you have to find how to navigate through all of this during your learning process. So this experience will be very helpful, and the skills you learn here can be passed on to the real life situation. Okay, so I think we come to the end of this very first part. Thank you for joining us.